Alrighty, we are looking at lesson 8.3, which is on the difference of perfect squares, just another way of factoring, another thing that another little tool in your tool belt of factoring. We've already talked about how to do it, and now we're just going to look at a couple examples, I think about 8, maybe, if we can rush through them in a decent amount of time, examples. So let's hop to it. We already did number 3, let's take a look at number 4, which is 100 m to the 6th minus 81 m squared. What? 100 m, oh, that's gross. 100 m to the 6th minus 81 m squared. Let's get a little closer here and try this one out. So this is two terms. I'm subtracting them, so it's good. And then I just got to look at each one to make sure that they're perfect squares so I can do the difference of perfect squares. Or I can, follow that little rule we learned in the previous lesson. 100 is a perfect square. The square root of it is 10. So I know I can just go to 10 there as my first one. M to the power of 6. 6 is an even exponent. To get the square root of something with an exponent, you just get half of the exponent. So this is going to be m to the power of 3. And then we have 81. That is a perfect square. It's going to be 9. And m squared, the square root of that, is going to be m. So here are my two square roots. And to get the difference of perfect squares, to get the factored form, the rule is once you have your two square roots, you're going to add them in one set of parentheses and then subtract them in the other set of parentheses, and you've got your answer. And just to make sure, we can check to see that this works, and I'll probably only do this check this one time in this video, just for the sake of time. We can do our double distribute, our double FOIL, whatever you want to call it, over here. So I'm going to multiply the 10m cubed. It's going to distribute to everybody in the second one, and then the 9m I'm going to distribute again to everybody in the second one. 10 times 10 is 100. M to the power of 3 times m to the power of 3 becomes m to the power of 6. I add exponents when I multiply like bases. That's those two. No, sorry, that's just that first one. 10m cubed times negative 9m is going to be negative 90 m to the power of 4. And we know that that's just going to get canceled out by this next thing we're about to do right here. 9m times 10m cubed is going to be plus 90 m to the power of 4, and we see that I've got a negative 90 and a positive 90 m to the power of 4. Those two like terms are going to cancel. And then we're left with 9m times negative 9m, negative 81m. And so we got back, when we did our check, right, this is just the check, we got back to the original, 10m to the power of 6 minus 81m. So we know that we did difference of perfect squares correctly there. Let's keep going, though, and that's going to be my last check of the video. X squared minus y squared and a squared. All right, so we've got x squared minus y squared. Okay, so it's two terms. I'm getting the difference between the two of them, and they're both perfect squares. X is a perfect square. X squared is a perfect square. The square root of it is x. And y squared is a perfect square. The square root of that is y. And now I'm just going to do the two, add them once, and subtract them once. So it'll be x plus y and x minus y. That is the factored form of this guy right here, right? Difference of perfect squares, just doing that. You can check it, and if you do your FOIL, your double distribute, or box method, whatever you want for this, it should get you back to that original. Let's keep going. We're away from the document camera for a minute. Number 6, a squared plus 64. Now, you see two perfect squares, but the problem is this is not a difference, right? It's a plus sign. I'm summing them. I'm not subtracting them. There's no difference there. So if we're trying to practice difference of perfect squares, we don't know how to factor this using difference of perfect squares. This would have to be a minus. So we just can't do anything with that. I don't know if it was a typo or not, but it's a good thing to remember, especially since this is our second video. I didn't get to share that rule until now. All right, next example. If the area of a rectangle is expressed as this weird thing, then the product of the length and the width of the rectangle could be expressed as, well, this just looks like a difference of perfect squares, and then 1, 2, 3, 4 different practice problem, different sample things that I could try multiplying to get there. Now you can do this as I'll FOIL this and I'll double distribute that and double distribute that, FOIL that to see which one gets me there. Or if you know your difference of perfect squares, and this is useful, we're done with the regions for this year, but this is useful for the SATs because it gets really quick if you know this method, right? I know, all right, this is a perfect square, subtraction, this is a perfect square. The square root of x to the fourth is x squared. So I know that both of my things need to start with an x squared, so it's either going to be choice 3 or choice 2. It cannot be 1, it cannot be 4, because 1 has just x's, that's not the square root of x to the fourth. And this fourth one over here has x to the power 4, it doesn't work out. So let's check this next guy. 9y squared, so I know it should be a 3y, because the square root of 9 is 3, square root of y squared is just y. I see 3y in both of them, but here 2 has a minus 3y and a plus 3y. That's what we want. We know that the answer must be answer choice 2. Let's keep going just because I want to be snappy. We got 4 more examples that we'll do, and then we're done with this lesson. It goes on to lesson 8.4. Let's do it. All right. X squared minus 64. We get to do that question that we missed from before. And you know what? I'll write this other one down really quick just so that I can stay on the document camera for a little while. Alrighty. X squared minus 64. So now it is subtracting. And it is two perfect squares. It's the difference between them. We can run it. Square root of x squared is just x. Square root of 64 is going to be 8, because 8 times 8 makes 64. And now I know I can just do x plus 8, x minus 8, and that is my factored form. And now one other thing just to mention, right? We're factoring these things, but this is asking to solve the following quadratics. This means to determine the x-intercepts through factoring using difference of perfect squares. Now, we didn't write this originally, but this was really equals 0. And again, this is like back to a couple lessons ago for what factoring is even for. It's for we have quadratics, which is the special u, and the solutions where it hits the, right, just a quick little review. The solutions are the two places usually, though sometimes it'll hit only once or sometimes it'll be floating above or below. The two places where it hits the x-axis are your solutions, and that's when you're equal to 0. And the reason we factor is because it becomes so much easier to find those solutions when it's in factored form as opposed to standard form. Here, I couldn't tell you when it's going to hit. Here, I see x plus 8 times x minus 8 equals 0. Well, that means if x was equal to negative 8, this part would be 0. So that's a solution for this equation. And if I made to make this part 0, it'd have to be, if x was 8, 8 minus 8 makes 0. 0 times whatever makes 0. So factored form, again, is just to show us, is just to show us the easier way to get the actual quadratic solutions. So here's the factored form. The solutions are just, you take the opposite sign from each of these guys to get the solution. Let's keep going. Trying to keep this under 15 minutes. I was going to say 10, but I think we're already there. X squared equals 16. Now you might say, well, we're done, right? There's no difference. It's not a difference of perfect squares, even though both of these are perfect squares. But what I can do is this is x squared equals 16. So I could say, hey, I can do minus 16 to both sides. That is allowed to move things around like that. That cancels. I'm left with x squared minus 16 equals 0. Now I can factor this, and the equals 0 is actually good. It's getting to that place where we have our factored form equals 0. We have the easy answer. This is going to be square root of x squared is x. Square root of 16 is 4, so it'll be x plus 4. And x minus 4 equals 0. This is the factored form. My solutions are going to be x equals negative 4 for this first one, because if I make x negative 4 plus 4 equals 0, makes the whole thing 0. Or x equals positive 4 for the same reasons. I'm going to a new page, and let's copy down these last two, and we're good to go. Ooh, example 3 I actually really, really like. 2x squared minus 98 equals 0, and 9x squared minus 4 equals 0. Okay. Let's do it. I kind of rushed on these, but let's go. Okay. You're looking at these, and it looks like, well, 2 is not a perfect square. Neither is 98. But if you remember your GCF factoring from last week, from a couple lessons ago, I see that 2x squared and 98, they can both afford to divide a 2 out from them. So I'm going to divide a 2 out of each of these guys. Oops, let's make sure that we're still in frame. Yeah, a 2 out of each of these guys. And if I did that, well, the 2 went away. So it's just x squared here. And then 98 divided by 2, well, we can just get our handy-dandy calculator over here and try that out. 98 divided by 2 is 49. So then minus 49 equals 0. And now I have a difference of perfect squares. This is going to be 2 in front, x plus 7, x minus 7. And I was able to do that quick because I know that the square root of 49 is 7. And then you just do plus and minus for them. My solutions for this are going to be x equals negative 7 for this first binomial, x equals positive 7 for that second binomial, and that's it. The 2 over here doesn't matter. It's not 2 plus x or 2 minus x. If this becomes 0, it'll times the 2. It'll multiply times the 2. It'll just make it go away, right? Let's finish up. Get through this video trying to make it go fast, because you can always pause and go backwards and, watch it a couple times if I'm talking too fast. Last thing. 9x squared minus 4. Perfect square, looking good. Even though this x has a coefficient, it's fine. I'm subtracting them. Let's go. Square root of 9x squared is going to be 3x. Square root of 4 is going to be 2. So I'm going to add them. And I'm going to subtract them. Oops, that's supposed to be a 2. I think I was drawing like a 7 or something. And then the last part here is after it's factored, this is kind of weird. I can't put negative 2 or positive 2 here because it's a 3x, right? So I need to figure out what times 3 would make negative 2 so that it gets over there. That's too much for the scope of this video. Just be happy with this being the factored form. I don't want to spend another 7 minutes going over getting the solutions for this. So that's our factored form. Good enough for me for this video for now. Thank you for watching. Hopefully I end this and see that it was less than 15 minutes.